Hello everybody and welcome back. Today we are going to be going over volcanoes. So this is everybody's favorite subject. Everybody always wants to know about volcanoes. So this is Unit 2, Lesson number 6. I cannot believe we are almost at the end of Unit 2, but we are definitely making our way along. So as always, you should have downloaded your interactive notebook pages for today, and this lesson will coincide with those. So let's go ahead and jump into it. So first, let's just define what a volcano is, and that's just an opening in the Earth's crust through which magma erupts, and we are going to talk about the difference between magma and lava. So magma, as it forms, and it forms in the mantle, so this is where the magma is located, it will flow upward through the cracks into the rock above it. Magma rises until it becomes trapped underneath layers of rock or until it reaches the surface. If it reaches the surface, that's when it erupts through a volcano. Magma that erupts through a volcano is called lava. So it's magma when it's in the mantle, and it's magma as it's making its way up through the volcano, but once it erupts and makes its way to the surface and is flowing, it's lava. Okay, so magma is inside the earth, lava is outside. So magmas that are high in silica are thick, light-colored, and slow-moving. So these are known as felsic lavas, and typically they are found, or a major component of granite. So if you think about granite, those come from felsic lavas. And then magmas that are low in silica, high in iron, are thinner, darker, and fast moving, and these are mafic. So mafic magmas are higher in iron, thinner and darker, and then felsic magmas are lighter colored, slow moving, and then thicker. So when we talk about the thickness of magma, what we're actually referring to is something called the viscosity. And viscosity is just the ability of a liquid to resist flowing. So if we think about something with a high viscosity, that's going to be something that's thick and that has a high resistance to kind of moving. So corn syrup, honey has a really high viscosity. If you pour it out, it takes a long time for it to come out of the stopper. And then also if you were to put it on a pan and put it at an angle, it would take it a long time to flow down. On the other hand, something with low viscosity is going to be pretty thin and liquidy, and it's going to be able to flow very freely. So think about baby oil. Baby oil is very slippery, and if you were to pour it out, it runs right out, and it can run very quickly. So there are different kinds of eruptions we need to know about in terms of volcanoes. So number one is a rift eruption. And these will occur at long, narrow fractures in the crust. And they do typically occur at divergent boundaries. Remember, at a divergent boundary, two plates are moving away from each other. These may be on the ocean floor or on land. And these are non-explosive eruptions. So you've got mafic lava. And examples of this would be spreading centers, such as the Mid-Atlantic Ridge. So this is where we're going to have really slow-moving viscous magma or viscous lava once it makes it to the top surface. So these are not kind of when you think of a volcano and you see the huge explosions and eruptions, this is not going to be that kind of thing. And this would be an example of one of these rift eruptions. So this is occurring at a divergent boundary. It's not really typically super explosive. So here it looks like this, lava is being emitted very quickly, but this is still not an explosive reaction. Number two is a subduction boundary eruption, and these will occur at convergent boundaries. So convergent boundaries where there are subduction zones. So again, this is not going to be continental-continental. This will be continental-oceanic convergent boundary. These are going to have explosive eruptions, and they'll be felsic lava, so they'll be lighter in color. Lava, steam, and ash are ejected violently here. And most of the world's active volcanoes occur at subduction boundaries. Okay, so when we think about where there are active volcanoes, they're going to be at subduction boundaries, where oceanic plate meets continental plate most of the time. Examples of this would be Japan, the Philippines, the Cascades, and the Andes. And here is an example of one of those volcanoes. This is what everybody typically thinks of when we think about volcanic eruptions. So just like earthquakes, volcanoes tend to occur at plate boundaries. An exception to this would be hotspots. So this is where hotspots occur at areas of volcanic activity in the middle of a lithospheric plate. So this is not at a boundary. This is in the middle of the lithosphere. Eruptions can be explosive or non-explosive, and the cause of them is really unclear. So examples of this would be the Hawaiian Islands and Yellowstone National Park. So the Hawaiian Islands were created from a hotspot volcano. So basically, this is in the middle of a lithospheric plate, so it's not at a plate boundary. But you have magma that is erupting, and these underwater volcanoes that are spilling this magma up and eventually creating new crust because it will harden. And so over time, what happened is that these hot spots in the plate, as the plate moves and keeps moving over time, it will create these islands in a chain. So if you look at Hawaii, you will see that all the islands are kind of together linked in a chain. It's because as the plate moves, the magma keeps erupting up and forming new land, which will eventually form the Hawaiian Islands. But again, that's not at a plate boundary. That's just in the middle of a plate. So Mount St. Helens was an explosive volcano, just something to be aware of. This occurred in Washington State. So Mount St. Helens was dormant for a really long time. I don't believe that they really knew that it was an active volcano. And then on May 18th, 1980, so 40 years ago now. Oh my gosh, I cannot believe 1980 was 40 years ago. Anyway, 40 years ago now, Mount St. Helens erupted in a huge blast. So magma rising inside the mountain over a period of week created a bulge on the north side. And then at 8:32, a 5.1 magnitude earthquake broke the bulge loose, causing the north side to dissolve into a massive avalanche. So the avalanche released pressure from the magmatic gases, resulting in a northern lateral explosion. It created a 17 to 18 mile fan-shaped path of destruction. This was a very, very intense explosion, and it did a lot of damage. And if you want to see a video on that, it is linked right here. So there are different types of volcanoes we need to know about. Number one is the cinder cone. These tend to be explosive with felsic lava. They occur at convergent boundaries at subduction zones. So again, where ocean meets continental crust. Cinders and rock particles are blown into the air. They typically are small mountains with steep sides. And we can find examples of this in Pyroclastic, Mexico. And then here is an example of a cinder cone. So you've got the central vent with rock fragments around, and then a cinder cone crater, and then they typically are small mountains with very steep sides. And here is an example of that in kind of animated form. And here is another. Here you have your cinder cone crater with these kind of steep sides on either side. A shield volcano is a non-explosive mafic lava. Divergent boundaries, rift eruptions, or hot spots. So these are not going to be the explosive, exciting like volcanoes we typically think about. The lava will flow quietly from the vent, and then the mountains will cover a large area. They will be gently sloped because the lava is very slow moving, and they typically are dome shaped, so like Mauna Loa in Hawaii or Iceland. And here's an example of a shield volcano. So you have this magma coming up. It will gently flow out on either side and create these gently sloping mountains. And here is Mauna Loa in Hawaii. This is a volcano. It looks like a mountain, right? Like a non-active mountain, but it is a volcano with these gently sloping sides that come from the magma being pushed up and then lightly flowing out. And then a composite cone volcano, also known as a stratovolcano, is mostly felsic or intermediate lava. They can be explosive and non-explosive. They typically occur at convergent boundaries, and a violent eruption will send up volcanic bombs, cinders, and ash. Quiet volcanic flow follows the explosion, and then alternating layers continue forming the mountain. So these typically are large mountains with steep sides, and they are cone-shaped. So Mount Fuji, Japan, Mount Vesuvius, Italy, and Mount St. Helens. So the volcano that buried Pompeii, Mount Vesuvius, would have been a stratovolcano. So what it's saying is that it's both explosive and non-explosive. So initially there'll be this like great explosion that will send ash and all of these nasty things into the atmosphere, and then the lava will continue to flow quietly afterwards. So you get kind of like a 1-2 punch. You have an initial explosion with a lot of emissions of gas and lava, and then you have slow flowing lava around it. And then this is a depiction of a stratospheric stratovolcano. And here is an example of this. So they're steeply sloped, but they are cone-shaped. And then they have these alternating layers. So just some dangers of volcanoes. There's something called a lahar mud flow, also known as a mudslide or a landslide. Lahar is something that we need to be aware of. This is a mixture of water, rock fragments, and sediment that flow down the slopes of a volcano. It can look like a big old mass of wet concrete, and eruptions can trigger one or more lahars by quickly melting snow, ice, or ejecting water from a crater lake. It can easily grow to more than 10 times their initial size, and they are typically associated with stratovolcanoes. So remember, stratovolcanoes are the ones that will explode and then have that really gentle lava flow. Atmospheric ash is dangerous. It can cover the sun and can change weather patterns as long as it's around. It's made up of dust fragments, rock, mineral, volcanic glass. And then unlike soft ash that's created by burning wood, volcano ash is actually hard, it's abrasive, and it does not dissolve in water. So it's not as environmentally friendly as like the ash you would get from burning wood. And then after an eruption, the ash in the air can be thick enough to block sunlight. If inhaled, it can cause breathing problems or suffocation, especially if you have asthma or some kind of respiratory problem. Severe eruptions have sent ash into the atmosphere, blocked some sunlight, and lowered temperatures worldwide for years. So we actually think, like when we think about the dinosaurs who died out, I know it's not a volcanic eruption, but the meteor that hit the Earth sent enough dust into the atmosphere to block the sunlight and change the climate, and that is what eventually wiped out the dinosaurs. It wasn't necessarily the explosion itself, but the aftermath. Pyroclastic flows are also a danger of volcanoes. This is a current of superheated volcanic ash, lava, and gas that flows from a volcano. It moves very, very quickly. And this is caused when an eruption column collapses or when a dome collapses. This is the most deadly part. So when we think about Mount Vesuvius that erupted and buried the town of Pompeii and killed all those people a long time ago, it was the pyroclastic flows that would have been so deadly because you can't really outrun that. It's very quick. And that is all that I have for you for volcanoes. As always, if you have any questions, make sure you let me know. And if not, I hope you guys have a really great day.